You better, if you're not sure what I just did, you can look that up, but this is actually creating an interpolation function which is defined by the time and the values, and then I call that by typing qtfun, and then I give it the time value that I currently want to look at, and it gives me the flux at that time. All right, so that's going to be useful. So what I'm going to do is I'm going to take that import command and I'm going to put it up at the top where I import everything else. Oh, look at that, I already have it. And I'm going to, right, qtfun is going to be defined here. Now, because of that, I need to replace this with qtfun, and get rid of these blocks. I need to come up to my function. Instead of that, is going to be qtfun, and this is simply going to be qtfun time. Now, let's see. First of all, let's see if this works for the steady state case. Okay, quickly restart and clear all output. It's a good idea to do that every now and then, by the way. So what I should see in a minute, right, there's the previous solution now, and I just reran it. So I'm going to literally just reproduce that. Okay, it's crashed. Why is it crashed? Okay, interpolation range. I think I need to be able to go beyond the interpolation range, so possibly extrapolate, basically. Sorry about this. Okay. Okay, I know what I'll do. I'm just going to make this range. Just so you know what's happening, if I understand this correctly, is that the qtfun won't work for one of my extreme ends. It does work though. Okay, why isn't it working? What I'll do, I'm debugging it now, is here's where I'm calling it. So let's just see print t here. Ponk. I think it's the t value that's crashing this. Okay, it's all working. New value of x, 104. Ah, okay. Why is it doing? Okay, this is the ODE solver. Is stepping up beyond the. Okay, I'm going to use an if statement to solve this. There's probably better ways of doing this, but I shall just simply, because I want to get this to work quickly. What I'll do is I'll say, if this is not going to be a good solution, right? But I'm just doing it quickly. So if time is greater than 100, then qn is equal to qtfun 100 else. Okay, let's see if that works. Oh, did I delete? Yes, I did. It ran. So does it plot? Okay, it's plotting. Curious. It's working, okay? It's plotting the output every 10 days. For some reason, this one, and I know why, I think. Let me I'm going to keep going because it worked, all right? It's worked. So now we have all the functionality we need. What I'll do now is I will make I'm going to put a pulse of infiltration, so a transient infiltration pulse. So let's say that Qt, when time is greater than, let's say, 10, and time is less than 20, equals minus 0.01. Did that work? Ah. Okay, how do I do that? Okay, let's just do this. Okay. Quick one. That's my infiltration pulse, you see? So I'm pulsing infiltration now. The model ran. So let's look at the output. Okay, so what we would probably want to check here is, hang on, did the model run? Okay, looks like the model did run. So let me plot simply t against psi. Yeah. Okay. So basically, it's working. I've done it. I've shown you exactly how I did it, and it was messy, so you can see how I do things. But the important point is I've replaced these lines here with these lines here, and what I'm using is linear interpolation to find the infiltration flux at the current model solver time step. Okay, there are other ways of doing it, but this is a fairly good way of doing it. That's it. So I will upload this script as well.